Hi, welcome to the April edition of the AJP-Heart and Circulatory Physiology video table of contents, or from the editor's desk. Thank you all for watching. We have a real treat this month. Joining me from Omaha is our deputy editor, Mary Lindsey. It's appropriate, I think, to have Dr. Lindsey here because this month she's the co-author on 3 of our guidelines papers in cardiovascular physiology. All will appear in the April issue. Mary, will you briefly describe the 3 papers and what they're meant to convey?
Sure, Irv, I'm happy to. The first I designed to provide guidance on best practices for the validation of antibodies used in Westerns and in immunohistochemistry. The second paper provides information on the measurement of cardiac physiology in mice. The third paper presents important information on rodent models of ischemia, reperfusion, and infarction, as well as other animal models of ischemia. Information on rodent models of ischemia, reperfusion, and infarction is important because it helps to set up some guidelines for these models. The 3 papers are meant to improve rigor and reproducibility in cardiovascular research, which should benefit all investigators, no matter which journal they publish in.
Thanks, Mary. I also want to refer our viewers to 3 outstanding podcasts that have recently been produced and on these guidelines papers. Go to our website, to AJP Heart and Circulatory Physiology, and click on the links for these podcasts. I know you'll find them very interesting. So I'm sure everyone's anxious to see what's in this month's issue, so let's get started. Van Skyke et al. Provide evidence that mTOR inhibition protects the blood-brain barrier in neurological diseases of aging by treating an Alzheimer's model of the AJP-J20 mice, which also have a low-density lipoprotein receptor null mutation genotype, modeling vascular cognitive impairment with rapamycin. They found that inhibition of mTOR abrogates the blood-brain barrier breakdown in these mice. Experiments using an in vitro blood-brain barrier model indicates that mTOR attenuation preserves BBB integrity through upregulation of specific tight junction proteins and downregulation of matrix metalloproteinase 9 activity. These data establish mTOR activity as a critical mediator of BBB breakdown in Alzheimer's disease and potentially vascular cognitive impairment, and suggest that rapamycin and other or rapalogs could be used for the restoration of BBB integrity. Cooper et al. Examined the expression level and cellular distribution of the pro-renin receptor in the subfornical organ of postmortem human brains to assess its association with the pathogenesis of human hypertension. Postmortem subfornical organ tissues were collected from hypertensive and normotensive human subjects. Immunolabeling for the pro-renin receptor and a retrospective analysis of clinical data were performed. They found that human PRR was predominantly expressed in most neurons and microglia, but not in astrocytes. In the SFO, importantly, the pro-renin receptor levels were elevated in hypertensive subjects. Moreover, PRR immunoreactivity was significantly correlated with systolic blood pressure, but not body weight, age, or diastolic blood pressure. These data indicate that PRR in the SFO may be a key molecular player in the pathogenesis of human hypertension, and as such could be an important focus of efforts to understand the neurogenic origin of hypertension. Kuzmiak-Glancy and colleagues determined the efficacy of a laboratory-based synthesis of an affordable perfluorocarbon PFC emulsion to increase perfusate oxygen carrying capacity without impeding optical absorbance assessments in isolated perfused working hearts. Hearts were perfused with Krebs-Henseleit or KH supplemented with PFC, increasing perfusate oxygen capacity by 3.6-fold. In KH perfused hearts, myoglobin was deoxygenated, consistent with cytoplasmic hypoxia, and the mitochondrial cytochromes, including COX, exhibited a high reduction state, consistent with oxidative phosphorylation hypoxia. PFC perfusate increased aortic output from 76 to 142 mL per minute and increased oxygen consumption, while also increasing myoglobin oxygenation and oxidizing the mitochondrial cytochromes. These results are consistent with limited delivery of oxygen to oxidative phosphorylation, resulting in an adaptive lower cardiac performance with Krebs-Henseleit. These experiments show that supplementation of KH with PFC reverses mitochondrial hypoxia and improves cardiac performance, creating a more physiological tissue oxygen delivery. Finally, in a rapid report, Chang et al. Tested the hypothesis that superoxide dismutase mimics could restore endothelial dilation in aging arteries by inhibiting Circ and protecting endothelial adherens junctions. Tail arteries from young and aged Fisher 344 rats were processed for functional, biochemical, and morphological analyses. Cell-permeable SOD or Tempol did not affect acetylcholine-induced dilation in young arteries, but increased responses and restored normal dilator function in aging arteries. In aging arteries, MNTMPYP decreased Circ activity, increased the intensity and width of VE cadherin staining at endothelial junctions, and increased VE cadherin levels in Triton X100 insoluble lysates, which represents the junctional protein. The results suggest an important new pathological role for ROS in aging endothelium, namely disruption of adherens junctions. Thank you for watching this month's video. Go to the table of contents where you can find editorial reviews and much more. We hope to see you at Experimental Biology in San Diego. Please stop by the AJP booth in the exhibit area. I invite any of you to stop by for our breakout groups on Sunday morning at 7 a.m. to provide input concerning the journal. We will see you next month, and don't forget to send us your best work now.